Welcome to this class. This is a physics class. We'll be looking at the topic scalars and vector. This is a topic under the branch of physics called mechanics. Now, in physics, we use some physical quantities. In short, physics generally has to do with physical quantities because uh, in physics, we carry out some measurements. Measurement is very important. What are the things that we measure? Those things that we measure are called physical quantities. In short, anything that has a measurable property or something that we can measure is called physical quantity. For example, length. The length of your table at home, you can measure it. The length of your field, of your stadium, you can measure it. Or the distance between 2 points, you can measure it. The speed with which a car is moving, you can measure it. The velocity of a car, speed, both are the same to some extent. You can measure it. When a driver suddenly changes speed, we say this driver has accelerated. So acceleration is another physical quantities. All these quantities are called physical quantities. They are used in physics also, and they have a lot to do with our real life situation. Now, these quantities can be classified on different bases. So one of the bases on which or with which we can classify quantities is based on the origin. If, or let me say based on derivation. So based on derivation, we have two kinds of quantities. We have the fundamental quantities and the derived quantities. I will not talk about that too much on this video because this video is strictly for scalars and vectors. Now, when we talk of fundamental quantities, those are the basic quantities. They are also known as base quantities. They are the basic quantities that they are the most important, that every other quantities are derived from them. They are formed from them. So examples, we have 7 of those ones. We have length, mass, time, temperature, electric current, amount of substance, and luminous intensity. We have those 7. They are called fundamental quantities. Then after that, we have the derived quantities. Those ones are derived from combining 2 or more fundamental quantities. So now, when we now, on the basis of measurement or on the basis of magnitude and direction, we can further classify quantities into two. We have the scalar quantities, or you call them scalars. Then we have the vector quantities, or you call them vectors. What do we mean by scalars? Scalars are quantities that have only magnitude, but they don't have direction. You can only associate magnitude with them. What do we mean by magnitude? Magnitude is size or numerical value. Numerical value. These quantities called scalars, they have values. Like when you measure their value, you can measure them and say that this is 3 meter, this is 5 centimeter, this is 8 kilogram. So you can attach numerical value to them, but you can't speak about direction when you are talking about scalars. No direction. You can't say they travel northward, eastward, southward, and westward. No, direction is not attached to them. But on the other hand, vectors are quantities that have both magnitude and direction. So when you are measuring, you can measure their magnitude, their size, and then we can attach direction to them. For instance, velocity. Velocity can we can say that velocity, we can measure the magnitude of velocity and say that this is 5 meter per second in the direction of so, whether eastward or northeasternward, and so on. Now, let me give you some examples of scalars on the board. First of all those 7 fundamental quantities, all of them are scalars. Examples under scalars, we have length, or distance. Length and distance are the same. So once length is part of them, that means height, breadth, width, anything that has to do with scalar, anything that has to do with length, thickness, they are also scalars. Then mass is also among them. Time is a scalar. Electric current is a scalar. From here, electric charge is also a scalar. Potential difference is also a scalar. Now, electric current, temperature, amount of substance, then luminous intensity. All of these are scalars. Then, apart from this, we still have area. Area, we have volume. We have density. We have speed. We have work or energy. We have pressure. So at least all of this. Then let me put electric charge. Electric charge is a scalar. Potential difference. They are all scalars. Now all of these are termed scalar quantities. We have many more of them, but these are very common in physics. So it's very common to know that these are scalars. Now, apart from this, let's talk about vectors. Examples of vector quantities. Now, a good example of vector is force. Force is a very common. So once force is one of them, then weight, anything that has to do with weight. Any kind of force, whether horizontal force or vertical force, they are all under vectors. They are under vector. Then we have velocity. We have acceleration. Even before all of this, displacement is also a vector. The displacement and distance, they are the same to some extent, but they are very much different in terms of scalars and vector, because this has direction, then distance does not have direction, but both of them are talking about length. So even though displacement is the shortest distance between 2 points, so we will be talking about that in subsequent class. We have momentum, then we have impulse. All of these are vector quantities. Then electric field. Then we have magnetic field. All of these are vector. We have many more of them. So in subsequent video, we shall be seeing more examples. Thank you for viewing this. We move.